Sasha. So how many of you people are using GitHub? Okay, and the rest are using GitLab, I guess? Okay, so if you're here for a presentation about someone bashing Microsoft or down-talking GitHub Advanced Security, this is not that talk. I will be most modest and humble about the topic and the content that I present, I hope. But I will show you some practical settings I think you should really consider if you are investing in GitHub as a version control system. My name is Johan Lindfors. I work at a cybersecurity company called Truesec. And if you want to know more about us, we are happily a proud member or the partner of this conference, and we have a booth up in the exhibit. So please join us afterwards and have a discussion. So why is this not a bashing talk about GitHub Advanced Security? Well, because GitHub Advanced Security is a really important product for GitHub. It is a product that is actually free for public repositories. So if you're an open source maintainer, for instance, you can use these features without any extra charge. But it's more like if you're an enterprise developer, if you have private repositories, then this is something that you really have to invest in. And that is if you want code scanning or like CodeQL in a CLI environment, or maybe scanning for secrets and such, which is important. And we know after having done tons of CI/CD reviews and penetration tests of GitHub systems and configurations, we know that there are some flaws or misconfigurations out there, which is why I think this product might still be really relevant. And if you are an open source maintainer, it is important that you use these settings that is available for you, but most likely isn't enabled by default, because you want to protect your, maybe not your users, but the ones that use your repository or your dependency of what you build as a product or a component in something else. You don't want to be a part of this supply chain attack that is one of the most interesting attack vectors available in the market currently. So you really need to understand these secrets, these settings actually. And if you're an enterprise developer, naturally you want to protect your users, your clients, your customers, maybe even your employees. Also, you might want to protect your IP, like your source code, which might be really important to protect from intrusion or ransomware or stealth, so thefts and such. If you're a consultant, as myself, you also want to really protect your clients. You need to isolate environments from each other and be really vigilant on how you behave around your computer and your devices when you attend different client setups or environments. So this is the first topic actually, or the first meme of this presentation. We as developers, we need to be more vigilant, not ignorant when it comes to security. We are a bit too naive when it comes to how much settings or permissions we should get. And we also notice when we talk to developers, like the more senior you are as a developer, the more permissions you think that you should have. And this is like a really catch-22 actually, because the more senior you are and the more permissions you have, the more vulnerable you actually become. So what we'd like to consider is like maybe be a bit more mature instead. As a senior or mature developer, you should say that I really don't want to be the weakest link in this chain or the dullest knife in the drawer or something like that. I don't want to be the one that causes all this malware to happen on my company. So I don't want to be the consultant that creates sort of a breach within Truesec, which is a cybersecurity company. That would be really embarrassing for me and for my company. So I really want to behave really vigilant around potential threats. Naturally, that means I also have to understand what potential threats are available for me, but I also need to understand the concept of risk. This means that we have to think a bit differently when we design code and we write code. And the things we can, the parameters we can use when we talk about risk is that this actually the probability of something negatively happening times the negative impact of that happen. So this is two different factors that we can actually leverage or discuss and mitigate. For instance, we can maybe mitigate the probability of something happening and see if we can eliminate the problem altogether, or we can minimize sort of like the negative impact by maybe having some protective measurements around data and stuff like that. So how should we behave? Because we can't consider everything that potentially be a risk in our systems or in the code that we write. So let me use this one. And this also means that I am really, really old, apparently, because I know what Linus Paulinien is. And if you haven't seen Linus Paulinien, you are really missing out. It's an awesome cartoon that was pretty much the only thing that was available for us in the 80s, meaning I am more than 50 years old. Which also means that I've actually been professionally more or less programming for 30 years. And, from a personal perspective, I've been programming more than 40 years. So I actually did my first programming course at Medborgarskolan here in Stockholm when I was like, I think it was 83. That's it's a long time ago. So almost 4 years. Yeah, long time ago. So we're going to use Linus Paulinien because everyone knows that when Linus walks this line, he meets these hurdles or some sort of objects that he has to behave around. So maybe we come to this pitfall or this pit in which there's a low probability that Linus is going to fall into this. And if he falls into this, the impact might not be that big. So maybe this is not the area of problem that we should focus on. Maybe not either talking about this, it's a high probability that Linus is going to fall into the pit, but the negative impact is not that hard. Then again, we all know, well, if we've seen Linus, that if he falls and he falls, because it's a he, isn't it? It must be a he. He always curses and such, so it must be a male. So well, if Linus should fall into this pit, there's a high impact of injury. But then again, it's not that big, so the probability is not that hard. It's not that big. This one is the major one. So this is something we really need to invest into. But then again, this might also be important for us to understand, like, if we fall into this pit, or if we identify a vulnerability or something that could potentially impact us really bad, then this is something we really need to consider. Because if it happens, it might cost us millions of Swedish crowns or dollars or whatever, depending on the currency we have. So this means that when we design software, we know this as developers, that we at least talk about the concept of writing something as secure by default or secure by design. Secure by default, meaning like if we write software, we write components or something that people's gonna consume, it should be secure by default. We shouldn't have to enable security features. They should be enabled by default. And secure by design meaning that we should also consider security and security features as part of the products. And there's actually a really interesting white paper written by CISA in USA, meaning that have a controversial statement around this secure by default and secure by design, saying that security features should not be something that you have to pay for. They should be included instead. And that is naturally something is controversial because that means that GitHub should probably open up all these advanced security features for free for everyone. But then again, it's a commercial market. They have to make money. So how do you balance this? But then again, it's at least an interesting perspective to have. There's some other things that is pretty cool in this white paper, which is really good read, is that you should also implement security features like monitoring or capabilities to identify potential vulnerabilities in applications by really exposing to your users that this security feature is disabled or you are currently in a vulnerable state. Consider like if you sit into if you park yourself or you sit in a driver's seat of a car and you drive away if you don't have the seatbelt on. There's like a blinking light. There's usually sounds that really lights up and says that you're currently in a really vulnerable position. There's not a lot of those features in products or systems that we use telling us that, hey, you're using this in a really unsecure fashion. Instead, it's like, yeah, you're just using it as is. So we're going to consider then sort of like a developer workflow or developer process. This is once again back to the early days of 80s, where we actually working on the devices and immediately contributed code up to production environments. This is not really realistic currently. Instead, we are investing in this version control system and CI/CD systems, which actually helps us deploy the code that we write and version control to the production environment. Then again, this might not even be relevant for you or reflecting onto you, because you also have, as you are developers, you are occasionally lazy, you want to be more productive, so you have some sort of extensions to your developer environment, if it's IntelliJ or Visual Studio Code or what have you. But you also have dependencies like third-party components that is being used either by the build environment or maybe your computer or your compiler or whatever, or your application on your runtime as well, which gets fetched down while you're building the application and then that gets shipped. So there are third-party components as well that we need to consider. Also, we most likely have these devices, the computer that I'm using, connected to some sort of back office systems like the ERP system or the HR system or the mail and business applications and such. And we most likely have different environments which we ship code to as well. So we have to consider all of these areas as part of the developer ecosystem or the process. So we're going to threat model this now, at least slightly, because we only have like 40 minutes, or actually I have 38 minutes left, or 28 minutes left, I should say. And we're going to use a perspective called the adversary perspective using this threat modeling. And looking at the adversary perspective, it might be interesting to come from a threat intelligence perspective, understanding what type of antagonists or companies are actually targeting our applications and what threats are they attacking our applications with. So if you want to know more about threats, we have this called the Threat Intelligence Report. I have a couple of them with me here. I also have a couple of them in the booth. So if you want to read more about this, it's a really interesting read. It's like 30, 40 pages or something like that, telling us what's the state of threat or the state of threat actors is in 2024. And if I should summarize it, so you don't have to read it, but you should, it's like we are actually making positive progress. We are seeing like the police and Interpol and Europol and such, they are making huge investments in areas, and it actually makes positive impact. That is a good thing. A negative thing might be like the big companies are currently not that focused. It's more on the small and medium-sized business, which might be interesting to people if you are currently, if you're yourself or representing a small and medium-sized business. How does that impact you? And also what it also talks about is like the supply chain attacks is still valid. So it's something that we should really consider. So if you want to read more about it, you should. So let's talk about the first threat actor, which is actually the user or the developer themselves. This is a hard one to talk about because as developers ourselves, considering ourselves to be sort of like the threat actor against the system is not that comfortable. So let's instead think of ourselves as people that might make mistakes instead of being like we want to make bad things or something like that. But then again, there are misgruntled employees that have like missed a paycheck or missed a pay increase or something like that, that might be really angry about the company. So how do we minimize the negative impact of what they can do in this system? Once again, considering like what is the probability that this might happen? Well, if we've done a really large reorganization or pay cuts and such, the probability might be higher. What is the negative impact? We should consider that as well. But then again, it is not that fun, I should say, to do a threat modeling exercise with developers and say that, hey, you guys, you might be the one that is the threat actor in this system. So instead, let's focus on this person, the developer, is doing something from another person trying to threat or bribe that person, like a criminal saying, like, I point a gun at you, or I send an email to you or a phone message with a picture of your kids at kindergarten saying, I know where your kids play, so now you're going to do this in the system. Those threats it's not that far away actually, and it's really hard to talk about as well because we don't want to be that personal. But then it might happen. Another actor is the cyber criminal, which you are using like phishing or ransomware and such, and also impacting this person somehow, maybe out of awareness, like maybe even doesn't know that the person's computer or device is now being infected by malware, and maybe spreading this to all of these different systems, which might be a way to attack these systems. Most likely, these systems are not the end goal, though, for this attacker. These might be some of the end goals. The source code might be the end goal, stealing source code, for instance. I was employed by, or actually contracted by, a big gaming company earlier, and that source code was like the entire IP. It shouldn't be stolen. It had to be like really protected. Or the other back office systems might be the end goal for this antagonist. Or maybe the production environment, the users of the systems that we build might be the end goal. So how they can traverse around these systems. So if you want to understand more about the threats against these types of environments, there's a really good OWASP project called the Top 10 CI/CD Security Risks for CI/CD naturally. And if you know OWASP, you know that there's tons of top 10 lists. We actually have a session at Truesec we call the top 10 lists of top 10 OWASP top 10 lists or something like that. It's a word bender. But it's a good project to understand the threats or the potential vulnerabilities against these environments. There's another one from Microsoft called the DevOps Threat Matrix, which is based on the MITRE attack pattern. Like looking from left to right, this is like how the different attack vectors that are being used by threat actors to get initial access, like attacking the organization's public repositories first and see how that can be impacted to actually then traverse and do like in the last stage exfiltration, like stealing source code or making something. This is also a really cool project. It's not for Azure DevOps. It's primarily for Azure DevOps, but it's really important for GitLab and GitHub and what have you from it comes from a version control system. And Google also have initiated a project called Salsa, if you're familiar with that. This is not maybe all of these threats as earlier mentioned. This is mostly discussing how we as developers can make proof of the things that we produce as developers is actually the things that our consumers actually use by building provenance, actually building SBOMs, like software bill of materials, and knowing that consumers can digitally understand all the components that we've built from the producer side and all of the dependencies and such, so understanding exactly what is being run in the system, which helps really good, a lot if we like do this software composition analysis, understanding which CVEs are currently attacking these third-party components and such. And we are going to talk about GitHub and GitHub Actions a bit at least. So let's start with threats against the source code, or actually how can we create threats or attack the source code? Well, some of the threats against source code is attackers want to submit unauthorized changes, actually code that looks like someone else has written it maybe, or just inject code that might be hidden somehow. That is one step that could be used to actually attack this. Or you can actually compromise the source repository build system to inject source code while something gets built, or maybe even impact the platform that is being used to build from modified source, making sure that you pull in source code from other repositories that you're not considering to be your actual point of truth. There is a really interesting or sophisticated attack. I guess you're all familiar with this. It was a couple of months ago, the xzutils backdoor. And if you haven't looked into this, you should really read into how this attack actually used a really sophisticated attack flow in which a person or an antagonist actually both created a lot of valid contributions to a repository, but also used multiple shadow accounts to build a sort of like a trust chain for that user. So people trusted that user to do solid work or actually valid work. But what that user actually did while doing valid work was actually injecting test files used for fuzzing. But when you coded these test files in a specific way, you actually had code that could be used to run, have a remote code execution in the systems of the clients. It was really sophisticated. It was identified by some sort of Microsoft researcher or something, like doing very specific things on his computers. But once again, it's a really interesting attack against the source code of a system. So how can we mitigate these types of attacks? What can we as developers do, or configurers of like GitHub? Well, at first, we should always use multi-factor authentication. And I know that all of you are using multi-factor authentication. And I know that all of you have told all of your parents and your siblings and your kids, use multi-factor authentication because it's key. You should really use this. We know, and it's written in this report as well, that the incidents that we discover or we help clients with, I think it's 90% of these incidents could have been avoided if people had been using multi-factor authentication. So it's something we should really tell everyone to do. So now I've told you, you go home and we tell your kids and everyone's happy. And then we can have single sign-on, naturally, making sure that we have managed identities, so like really provided identities for onboarding and offboarding and such, which is good. Filtering on IP or domain names might also help, understanding that people come from a very specific area of the world or a specific area of the internet or something like that when they contribute source code. And I also, this is something that is kind of interesting. How many have, I shouldn't actually, you should never bring up your hand on this. Everyone is using passwords on their SSH keys. Yes, good. And also for the personal access token, that is like the standard to use. Not a blank password, that is not a password. That's like skipping a password. You should have a password or passphrase on your keys. And then again, we should also use branch protections. All of these protections I've just mentioned are kind of interesting because they are using technology to be sort of like barriers to threats or vulnerabilities that might happen at a system. The last one, code reviews, could be potentially considered also sort of like a mitigation where we say we're using technology. We can use SAST tools like static analysis naturally. But code reviews is usually getting someone else to review my code, meaning like we have this 4i principle, like someone else has to look at my code and say that this looks good, and then we can merge it. But there are some flaws in this process as well. So let's consider a simple Git workflow where we have the main branch, which is actually the current one, the code is being run in production. Then we have the developer branch, which we usually create our forks around, or the branches for features. And then we write code and commit these changes to this feature branch. And then we say, I'm done. I want to merge this. I want to create a pull request. So I create this code review. Someone approves it, and someone merges it. Maybe someone else, maybe me or someone else. There's a flaw here as well. And I guess you already are familiar with this one. And this is this one. What if someone makes a change after it has been approved? What is the default setting? What will happen then? It's still approved, yes. So people, maybe I or someone else, can make change to my feature branch it has been approved, and then someone merges it. So these settings is not enabled by default when it comes to GitHub. Like you should, first of all, you should require a pull request before merging. That is, it might sound like a common sense now because we're talking about this topic, but it's not a default setting. I've enabled it to get this screenshot. But then again, all of the other checkboxes is also not enabled by default, meaning this is not secure by default. So you have to actually be very explicit to say that we need a couple of required approvals, like maybe 1 or 2 or 3 people. And then again, you should also dismiss stale pull requests and require an approval for the most recent reviewable push. So that you have to be really explicit. You need to understand these settings and enable them. And also understand that enabling these settings will break your current workflow a bit. You might lose some of the velocity, but then again, becoming a bit more protected. So going back to code reviews, if I tell someone then, I want you to review my code, and we have this 4i principle, then we have this type of code, which might be interesting. So a GitHub action, someone make a change, someone does the code review and say, yeah, this looks good to me. Can anyone just spot what this flaw is? If you have attended the booth, you might already have had this discussion. This is an example of a command injection, which is sort of like a SQL injection, but instead it's being we'll be able to run code in the GitHub runner by every comment gets added to this issue. This is GitHub action in YAML once again. All the body of this comment will be echoed into the GitHub runner. And since this is a bash script or bash command, if I just type semicolon and then I can write pretty much anything as a shell script and it will run code. So it's a command injection. What I mean with this is if we have code review as a policy or like a 4i principle, we also need to understand that the skill set required to do code reviews is hard. So after having heard, at least I've heard the discussions around AI earlier, that we're losing our jobs because anyone can cut and paste or cut and copy code from AI or just introduce them to our source code. Well, we need senior people that have a senior set of mindset and skill set of doing these types of reviews. And it requires experience, actually. So you need this still. So code review is good, but you need to understand what you are reviewing. And you also have to give guidance and saying, you should review the code for this. The code should do what the ticket maybe says that the code should do or something like that. Or if you want to do a code review for security problems, then you should use security people to do that code review. Okay. Then we have threats against the dependencies, like all of these extensions. Well, these are also naturally very interesting, and I think you are familiar with some of these potential confusions or maybe potential issues as well, or threats. Like the public dependency confusion, if we have repositories or registries such as Artifactory or something like that, in which we actually cache some of the dependencies that we bring into our project. And we are mixing because we are only keeping some of these dependencies in the cache or in the Artifactory, and then we have some public repositories as well with dependencies that we pull down. The mix of this is a hard one to manage, and it's a hard one to get really good from a security perspective. Another attack or threat is a public package hijack, meaning like if someone changes a name or someone else takes over a project and changes name. That might also be something called a repo jacking, actually potential threat, and actually injecting code for that. Or typo squatting, we're actually creating a repository or creating a dependency that looks like something else and hope that someone will just bring that instead into the build tree instead. An interesting threat against this, if you want to read up on it, is called event stream. If you're familiar with this, it was also a really interesting attack where someone in 2018, on September 9th, did once again a valid user who had done some work on this repository, helped this event stream project to inject a flat map third-party component to do a flat map on the components in this. And then 7 days later, on the 16th of September 2018, he or she updated this project and said, I removed the third-party component and just did an actual implementation of the flat map functionality instead. In these 7 days, this repository, I think it was used 1.9 million times or something like that. And they pulled down then this flat map third-party component, which actually had a post-install step in the npm package or the package.json, which actually injected code that stole crypto wallets. Also, really sophisticated attack, but it was done like because someone just cloned something and then npm install and then stuff ran. In 7 days, it stole a lot of money. Interesting attack, but something that we really should consider. So some of the mitigations then against dependency threats is, well, we should really naturally fix this, how we think about private and public registries or Artifactory and packages and such. We should also probably focus on pinning dependencies, not going for the latest or something like that. Instead, we should really be really explicit about packages we use. And this is interesting because this might be the way that we consider to use an external action here from by using a tag and saying that I'm being explicit. I'm going to use the 1.0.1 tag for the JavaScript action tag. What is the problem with this? Yes, you can retag it. Tags are not immutable, meaning like you can actually remove this and recreate this tag against something else in the register or in the commit history. Meaning this is a much more explicit way saying this is the commit ID of the version I'm going to use. This is much easier for us, or much more secret, or much more better from a security perspective. So this is the behavior that we want to use. Another aspect of dependency threats mitigations is vendoring. Are you familiar with this concept? Also looking back at, well, this means actually that all the third-party components we're going to use, we're going to fork them, and we're going to use our own version of these dependencies. So we're only going to use open source repositories, or like GitHub repositories. We're going to clone them or fork them, and then we're going to run our own tool chain, our own process on this source code. And then we're going to either pre-build them, or we're going to build them from source all the time. That is a really efficient way from security perspective to have your security perspectives applied on this project. But then again, how do you manage or handle changes, like if the upstream gets a patch or an update, or you make, this is a nightmare, if you make changes that you don't want to contribute back to the upstream, but you still want to pull down like patches and such, it's a nightmare. It can be handled, but then again, you should consider it. It's a really efficient but really costly mitigation. You should probably have sort of like a third-party team, sort of like that does this managing, but depending on how many third-party dependencies you have. But then again, if you are using like React, then you have at least, I should say, maybe 600 to 1,000 third-party components just by doing like a file new project in React. It's not one, it's not just React, which is the third-party component you're using when you do React, because React is built on a chain of transitive dependencies that you are not like owning, and you don't write the code, but it's your responsibility actually when you ship software to your clients that it doesn't break or actually doesn't hurt your users. So you still have to take responsibility about these components. So how do you do that when you do these type of the build trees and such? And one thing that you can use is a GitHub action called the dependency review action. This is something you can just pull down, and you can review that source code as well, because it's available for open source. And it will actually run when you do like pull requests and see, are we making any changes to the dependency tree in this pull request that is breaking either license schemes or versioning schemes, or maybe like introducing new CVEs or something like that we don't want to have prior to actually shipping something or actually committing something into the main branch or development branch. So this is something you can use. It's a really good tool. It's free to use. Another tool that we also recommend occasionally is the OpenSSF scorecard. This is cool because this is a tool that also has a GitHub action. You can also run it as a CLI. And it has like 19 different parts of it that it actually measures and creates sort of like a aggregated score on how well this open source project is maintaining it from a security perspective. And then you can create your own perspective or like an awareness of, we don't want dependencies that have a score worse than 7.5, for instance, aggregated. Or we might even go even deeper and say, looking at like the dependency review action, I ran this a couple of weeks ago. It has 8.2 of 10. I ran it on the Newtonsoft JSON. So if you're familiar with the Microsoft ecosystem, this is the most famous JSON parser or serializer, deserializer used in .NET. Everyone uses it. 2.9. That's like terrible. Well, it's scary. But then again, looking at the aggregated score, that says that Newtonsoft is really bad. But it has the last one, the vulnerabilities. There's no known vulnerabilities in Newtonsoft, which is a 10. Looking at the dependency review action, there's a 9 score. So there's some flaw, some vulnerability in that dependency that has. So that score might be more important for you than this one. You have to at least make an assumption, or you have to make an aware choice to say that this is the score that we are looking for. And you can investigate like all of these different topics and say it should be maintained. You should have multiple contributors. You should have a license. The project should use SAST. You should have a security policy defined and being run. You should have branch protections or something like that. So it's a good tool to use and see if we want to use this open source repository or this dependency in our product. And then make some sort of like, now we at least know how good or bad it is. So this is all some things that you can hook into in your pipeline and use it in GitHub. Still, all of this has been free, I should say, so that's a good thing. Then we come to this interesting aspect as configurers of this. So how do we enforce this security for everyone? Because everyone knows, like, if you're an administrator or if you have some admin rights on repositories, you usually can, like, I'm going to allow force pushes if I'm an administrator or something like that. But then again, we can override this setting in some path in this organization. If we're an enterprise organization, we might even override that setting, meaning like there's a tree of what can an administrator actually do when it comes down to administrative settings in GitHub. So the first thing you should consider when you're having administrative accounts for GitHub is those should not be developers. It's so common we see, once again, that the most senior developer or the tech lead or something like that in that project is also the admin of the GitHub repository, or maybe the GitHub organization, or maybe the enterprise as well. You should really have sort of like break the glass accounts or something really, maybe even two people that have parts of the key or something like that should be able to change these settings when it comes to these administrative things. So if I've tried to teach you or tell you anything in this presentation, is the first thing, we need to be vigilant, not ignorant. We have to be a bit more pessimistic and maybe a bit more mature when it comes to thinking about security. We also need to start thinking about secure by design and secure by default, meaning we have to consider these aspects not only when we write code ourselves, but also when we install products or when we configure products. Make sure that it's secure by design, secure by default. Also, we need to have a proper skill set. If you feel uncomfortable with doing security work when it comes to fixing security-related bugs, bring in people that have security mindset and security skills. They are happy to help, and it might even be more comfortable, meaning like maybe you're not responsible for that change or something like that. It might be something that we can feel a bit more comfortable with. So these are three of the topics I think you should bring with you in this presentation. I also want to give you 3 personal tips. And if you haven't understood it, you should really use multi-factor authentication. I think I was a bit transparent and clear about this earlier, but you should. The second one is you should also use a password manager. So is everyone using password managers? Yes. And get your kids using password managers as well. The easiest way to get your kids to use password managers is just inserting the password for Netflix in the password manager and make it like 50 characters or something like that. They will just use it once and then they're happy ever after. And then you can just throw every shared streaming service or what have you in this password manager, and they are thanking you for it. The third one, this might be something that is harder to grasp or accept. We need to isolate and separate our behaviors or our environments. This means that when I'm presenting here on stage, I'm using a computer that is completely disconnected from Truesec. This is a personal device. I'd be terrified, not terrified, but I'd be devastated if it got stolen, but then again, it wouldn't hurt Truesec. I've just the PowerPoint template is here. That's pretty much what you can get. But then again, it's not that hard for me. That's not. Also, I'm using a password manager. I'm using one password from a private perspective, but I'm using a different KeePassXC for my professional content. So I'm having like cryptographically isolated password managers, isolating and separating my personal context from my professional context. And I'm using YubiKeys, I'm using different types of protective measures and such, just trying to be a bit more pragmatic and isolating. So I carry a couple of computers, a couple of devices with me, but it also makes me feel much more comfortable by presenting, and also understanding that the computers I have with me in my bag is protected at least from anything else. So a good thing with password managers is most of these password managers also have CLIs. So this is something I use for 1Password, and this is also sort of like a personal preference and maybe a recommendation that you could also help both your personal life, but also some maybe you can use this for your team to try to mitigate the issue with committing secrets to source code. Because this is a script that I'm using to run the OSF scorecard against different types of repositories. So I'm passing in a repository, and it's gonna run the CLI for 1Password to read the token for this, the personal access token for GitHub to be used by that command. Meaning I can commit this script to any source tree because there's no secrets in this. Maybe the path, the vault and the entry and the properties is somewhat secret, but then again, not that hard to understand. So it's something that we can also use to share secrets, even though we commit them to source code, and then we can have the password manager, which actually is the area where we actually keep these shared passwords protected, which gets synced back and forth through these vaults and such. So this is also something that I think you could bring with you, and it makes me a bit more comfortable when I do signed commits and when I do SSH keys and such, because I can use this technology to use that and never be afraid of committing anything to source. And if you happen to commit something to source as a secret, naturally you should remove it, and you should also immediately rotate it. It's common sense, but then again, we usually see that it doesn't happen. People just remove it from source code and think we're fine. So rotate all those keys. And with that, I'm a bit surprised. I'm done. Thank you very much.
Are there any questions?
You do know that there's one more session, so I'm not keeping you from the beer or something like that. Please.
Very nice. I was thinking of, like, with the improvements of AI and the usage of using AI more in development, do you think that it will become more security risks and more dangerous? Like the bad guys will have more tools in their toolbox, or will we be more stupid and do security risks as developers using AI?
Yes. No, I'm just sorry. So, what is the impact of AI when it comes to cybersecurity and the threats and how antagonists are using it and how we should use AI ourselves? I think it's obvious that they are using these technologies already. They use it, for instance, to create more phishing mails that looks more like it's been created or written by a person instead of a bad translator, something like that. That is one way of they're using it. So we should also invest as security researchers or security developers or whatever in AI, understanding the concepts and how we can use similar tools to protect ourselves. But then we should also use technology, because technology can most likely identify these type of changes easier than we as people do. And we do that already, like in SAS tools and DAS tools and such. So we should use these types of technologies even further. I also think that there's more need for improvements and research in creating domain-specific language, or domains in which we can actually teach AI how we can use AI for our own code, looking at like how source code is being used currently. Like there's a lot of bad code out there, and if we can teach AI on our domain, like the code that we have written, maybe we can be a bit more, we can have a bit more trust in that code instead of just trusting blindly everything is available in Stack Overflow or whatever. So that's also an area I think we should invest more in. But I think we should be vigilant once again. Also, we should help our dear friends, data analysts, that are, I'm trying to be careful here. It's not all the people that run Python, but mostly it's like people that earlier didn't have computer programming skills that are very good with data. What we are seeing now is they are super excited about AI. So they are creating these workflows and running all of these queries and ChatGPT and prompts and everything around, against data that they have extracted onto their devices without any mindset around security and such. Because they're not considered to be developers, meaning they don't get impacted by all this build version control or like protective measures that we already have, and they don't have the mindset that we also have, like be a bit more pragmatic or cynical. So we need to teach them these behaviors and how they protect the data that they extract, and then they suddenly make available just by creating like public queries or public exposures and such. So that is something which also we should consider, and that goes back to once again, being a bit more pragmatic, being a bit more mature. Yeah, I think that's, yeah. Any more questions? Please.
You mentioned that it's a best practice to use SSH keys, right? So is there any exceptions that you can still use HTTPS?
So let's see. I had a recommendation of using SSH keys. Well, SSH keys is one way to use, like for signed commits and maybe even like doing pull requests or committing code to GitHub. I'm not sure if it's the best practice, but it's one way. Personal access tokens is the other one. You should at least, if you're using SSH keys, you have to protect them, because if you're storing your keys on your computer, you have to have, if you're using Mac, you're fine, you have this encrypted file system. On Windows, you have this BitLocker that encrypts it. You should protect the keys, because if your computer gets stolen, those keys, if you don't have a password, anyone can contribute code to the repositories that you own.
Human to machine communications. What about the machine to machine communications?
That's not my area, I should say. So I'm not gonna. So, yeah. Maybe you can talk to some of my colleagues here. They might have. I'm just throwing at them then, because they are way smarter than me, and I'm just being modest now. Okay. Thank you very much. Thank you.
Please